You can't write it down, you don't have time. Okay, you're going to need a lot of examples when it comes to graphing, so I have a ton, so everyone focus with me. So these are the steps I take to graphing a rational function that's not a shift from the parent function. First, factor everything. There are times when factor form is better, and there are times when standard form is better. When I'm doing end behavior, I always want standard form, so I do like both forms. Second, identify the discontinuities, which are vertical asymptotes and holes. Third, I identify horizontal/end behavioral asymptotes, which comes from the degree. And then fourth, all we have to do is fill in the graph by XY points, right? Isn't that how we graph anything? XY points. Now, I personally usually start with my x-intercepts, and then a lot of times I'll use my y-intercept, but we can use any points, any XY points. You'll see why the x-intercept is usually really useful. And then we're just going to draw rough sketches after that. So here's my first example. So what you would do is first factor the top, factor the bottom. That's done. Then you're going to identify your vertical asymptotes and holes. So my vertical asymptote is x equals -3. So then I would go and I would then take my highlighter or whatever and go to -3 and put in my dotted line. Any holes? No. So moving on, none. My horizontal asymptote comes from the degree on top and bottom. It is the same. The leading coefficient is -1 divided by 1, isn't it? Yes. So y equals -1. So I go to -1 and draw in my horizontal asymptote. Now from there, guys, think about this. Everybody think about this. Your domain is all real numbers except x cannot be -3. So don't you know that your graph has to connect all the way from -infinity to infinity somehow? True? Yes, except it'll jump over this value, right? All right, so we've got to have graph going this way. We've got to have graph going this way. So I always say to myself, I need graph on this side of my vertical asymptote and this side, true? So let's figure out where. So let's now, all you have to do now is plot some xy points. I always start with x-intercept personally. My x-intercept comes from the numerator. So I say -x minus 2 equals 0, -x equals 2, so x equals -2. -2, 0 is my x-intercept. Now, do you guys see how in that section, I have enough information to now draw a rough sketch? Don't we know it's definitely going to approach this asymptote and never cross it? Now, it's going to come down. Isn't this where it crosses through? That's what an x-intercept is. And doesn't it, by definition, approach this asymptote? Does that make sense to everyone? All right, great. Now, this is another thing, if you really get good at this, think about this. Our graph then can be up here or down here, right? Now, let's think about this. Were there any other x-intercepts? No. Therefore, is it possible to be up here? No, because then it would have to cross the x-axis again. Therefore, it must be in this section. Now, let's say you didn't think about that. Like, I used to never even think about that. What I would do is then I'd go plug in a value on this side of the vertical asymptote. I'd go plug in -4 into my function and then see where the point is. Does that make sense? And then when I plug in -4, I would have got a value down here, so I would have known it was in this section. 2 ways to do it. The better you get at thinking about things, the easier it is to graph. Does that make sense to everyone? Okay, let's continue to get more and more advanced. Literally every single example I have has something different happen, and that's why I have so many. So let's go again. Factor the top, factor the bottom. So on top I have a 4x. On bottom I pull out an x, and then left was x squared minus 4. X squared minus 4 factors to be x plus 2 and x minus 2. Okay, great. Now from there, we're going to do our steps of identifying discontinuities, vertical asymptotes and holes. Vertical asymptotes are at x equals -2 and x equals 2. So I'm going to go to -2, draw in my vertical asymptote, and at 2, draw in my vertical asymptote. Okay, I do have a hole at x equals 0, so I divide it out and write down the new function. 4 over, I'm going to put it back in standard form because that's my preference. That doesn't matter though, I could write it in factored form, x squared minus 4. All right, there's my new function. So it's at 0, we don't know, comma, what. So plug in 0, so I get 4 over -4, which is -1. So I'm going to change colors, I'm going to graph in red. A hole is just a point on your graph that your graph crosses through. So 0, -1 is an open hole. Okay, let's move on to horizontal asymptotes. I like to look at standard form. You can use the original or the new. It does not matter, you'll get the same answer. I'll look at the new. The degree on top is smaller than the degree on bottom. Picture yourself plugging in 1,000,000. 4 cut up into 1,000,000 pieces, 1,000,000 squared. It is pretty much 0. So y equals 0 is my horizontal asymptote. Does that mean for sure there are no x-intercepts? Not necessarily, because it can cross horizontal. Now, how can I, from here, I'm going to plot x, y points. Now, guys, once again, I need points on this side of our asymptote, don't we? And on this side and in between here. I need to figure out what's going on. Do you guys see? So then from there, I'm going to pick some points. So first of all, I like to do x-intercepts. Look back to here. Is there any x-intercept? None. It cannot cross the x-axis. Does everyone agree? So if that's true, guys, look, we could just know that this down here has to remain down here, doesn't it? Can it go up and cross through? No, or there'd be an x-intercept. Does that make sense? So right here, I could just go ahead and have it approaching my asymptote. Is that a perfect sketch? Not necessarily, but that's not, we don't need a perfect sketch. So what if you were like, I'm not sure. Could you have plugged in 1 if you so desired in your heart? Yes, and then you would have known where to go. Okay, now what I am going to do is plug in 3. Because is my graph up here or down here? We don't know. So I am going to plug in 3. So everybody, plug in 3 with me. That would be 4 over 9 minus 4. True? 4/5. So I'm over 3 and I'm going up 4/5. That's plenty. All I need to do is now graph, fill it in. Will it cross? No, or we would have had x-intercepts. Do you guys see what I'm saying? Okay, let's plug in -3. If I plug in -3, I'm going to plug it into my simplified one just because I want to. I could plug it into the original. Don't I get 4/5 again? So I'm at -3 up 4/5. So then I know I must be up here approaching my asymptotes. Now look left and right. Is it connecting from -infinity to infinity and just skipping over the discontinuities? Yes, so you filled in the graph all correctly. Okay, questions on that? Was that pretty easy? Awesome. Okay, awesome stuff. Okay, let's keep going because different things happen every time. I don't know why I have this one written down twice. I have some weird stuff on this. I need to fix it. Okay. All right, so what you would do is say factor the top. Well, this top does not factor, everyone. So you'd say, okay, if the top doesn't factor, then it's not going to divide out with anything on bottom. Therefore, that must be a vertical asymptote at x equals 2, right? If it can't divide out, it's not a whole, it's a vertical asymptote. Okay, great. My horizontal asymptote, because there is no hole, so I'm moving on to horizontal, degree 2 divided by degree 1. We've got to do it, right? It does divide, so we've got to do a synthetic or long division. I'm going to do synthetic division. So using the 0 as a denominator 2, I put in 2, -3, 3. Add straight down, multiply up, add straight down. Do I need to keep going? No, because I don't care about the remainder. That is what I need. So I have y equals 2x plus 1. There is my slanted asymptote. So my y-intercept is at 1, and my slope is 2. Up 2 over 1, up 2 over 1, up 2 over 1. So there is my slanted asymptote. Okay, awesome. Now we're going to just fill in the graph. So first of all, I'm going to make an XY chart. Now you don't have to do the same points that I would choose. I usually say, what's my x-intercept? But the problem was the top didn't factor. So I don't want to do the quadratic formula personally, so I'm not going to choose to do that. I'm going to pick other points. Like, I'll plug in maybe 1. Sure, let's plug in 1. Maybe even something on this side, like maybe -2. I'll plug in -2. And then I'm going to plug in something on this side, maybe like a 3. So everybody take one, please, and plug it in. Please do it because we need correct values. So I need a few people to do it so that if you don't get the same answer as someone, you can speak up. So tell me the y value, then I'll be able to do a rough sketch here. For 1, you got -2? Yeah. Awesome. For 3, I got 12. Good. Anyone -2 for me? No, can't be right. Can't be right. Okay, awesome. Let me see if that's enough to get a graph here. So I'm going over 1 down 2 units. Yes. So can you see where you're at? Which section? That section, right? So aren't I just going to be like, and is it a perfect sketch? No. Could there have been x-intercepts? Yes, because quadratic formula can give imaginary, but it can give irrational, right, which are decimals. So rough sketch is all we're looking for here. That's good enough. Everyone sees. Okay, from there, let's plot over -2 down 1, 2, 3, 4. Well, that makes sense. Aren't we in the right section still? All good here. Okay, over 3 up 12. That puts me in this section. So up here and following that. Now look, does it connect through? Does it go from -infinity to infinity? Yes, doesn't this go down forever? So isn't it going to -infinity? Is it going that way forever? Yes, right? So it is going from -infinity to infinity, connecting through.
How do you know how many
Every one's different.
So if you plug in like a -6,
No, if you plug in -6, it'll just be down here in the right section. Does that make sense? It'll put it in the correct section. So if you're ever not sure what your graph looks like, can't you just plot as many points as you want? Yeah, okay. So this graph could have happened 2 ways. It could have been in here, but it also could have been like this. Now, here's how you can kind of know if you're missing something, if you've done something wrong. It would not be possible for a graph to be on top of a graph. Meaning, let's say you were plotting points and you found this, and then you found something up here. Wouldn't this be overlapping? This would fall in this and this would make it not a function. That's never going to happen. You've made an error in your calculation somewhere. Does that kind of help you see that you'll never have a graph on top of a graph? Okay, awesome. Okay, couple more examples. Stick with me because they all have something different happen. So back to the top, back to the bottom. The top factors to be x minus 4 and x plus 2. The bottom has an x and an x plus 3. So I have vertical asymptotes at x equals 0 and x equals -3. No holes since nothing divides out. There really is a reason I'm doing all of these. I promise they're just all, they have different elements. Okay, then our horizontal asymptote, I look back to standard form, must be at y equals 1. Okay, awesome. Now from there, I'm going to plot xy points. I always start out with x-intercepts personally if it's easy. So I have an x-intercept at 4, 0, and at, so I'm going to do that, over 4 of 0 and over -2 of 0. Okay, great. So now if you look on this side, we know how this is going to fill in over here. Isn't this the point? So it must be coming up by this asymptote and coming down like this. True? Okay, and then now in here, I don't know for sure what's happening because, well, it just depends. Because look, could I come down like this and cross and go up? Could I come down and go like that? So I don't know for sure. So I'm going to maybe plug in just one value like -1. So let's plug in -1. I'm going to plug it in here. So that would be -5 and then times 1 divided by, plug in -1, -1 times 2. So a negative and a negative is +5 halves, which is 2.5. So -1 up 1, 2.5. So I can see exactly what's happening, right? Coming down like this, following this asymptote, it must be crossing through our 0 and then heading up by this asymptote. Should we be alarmed it crossed a horizontal asymptote? No, no, no. Okay. Now, I'm missing graph, right? You should know that you can't stop. You need graph going here. So it's either up here or down here. So let's think about this. We could plug in like a -5, couldn't we? But also, couldn't we think about, was there any other x-intercepts? So it could not be down here, true? Or it's going to cross the x-axis. So therefore, it must be up here. Awesome job, guys. So we had our 2 x-intercepts and only those 2, right? We had already graphed them. So if it was down here, wouldn't it have to cross the x-axis again? Does that help? But once again, if you were to plug in a point, that would work too. Okay, awesome. I know it's a lot, okay, but I really just think you need a few more examples. I'm sorry. We're going quick. It's just that all are different. Okay, I'm sorry. Let's go quick. So right here, you'd say your vertical asymptotes are at x equals 2. Do we have a hole? at x equals -1, divide that bad boy out, write down your new function, -1 times x minus 6 on top, on bottom I have x minus 2, so then my whole is at -1 comma, plug it in -1, so that would be 7 thirds, positive 7 thirds, negative 7 thirds, because that's positive, that's negative. -7 thirds, which is -2.3, everyone. So I have the whole, I'm going to change colors, -1 down -2.3. So there's my whole, roughly right there. Okay, awesome. Horizontal asymptote, we can look here and here. We can look at original or this. Degree on top and bottom is the same. Therefore, divide your leading coefficients. Horizontal asymptote is at y equals -1. So then let's go ahead and make an XY chart. X-intercepts are at 6, 0, because they come from the top. So I already know now, right there, this side of the graph must be filled in like this. Then right here, this is a point on the graph. Do you agree? So we know that this has to be down here. And we're done. Okay. If you weren't sure, you could plot more points, but hopefully we're getting where we don't have to. Okay, only a couple more. Okay, so on top, we would factor it to be x minus 4 and x minus 3. Something actually really interesting happened with this one last hour and we got stuck. So, okay, x minus 4, x minus 3. Then divided by, what should I pull out first? 4, and then left would have been x squared minus 4, which factors to be x plus 2 and x minus 2. Okay, awesome. So then let's go ahead and plot our vertical asymptotes, which are at x equals -2 and x equals 2. Maybe you guys can help me think through this weirdness we get involved in on this one. Okay, and no holes, agreed. Horizontal asymptote back to standard form must be at 1/4. Okay, so right here, like right here, roughly. Okay, so now from there, we're going to make an XY chart, because that's always what we do, and I'm going to plot x-intercepts. My x-intercepts are at 4, 0, and 3, 0. Okay, so kind of weird. All right, so we're going to come back to this side of the graph. Let's go to here. So we know, okay, if we plug, let's plug in a value for sure. Let's plug in maybe like 0, because 0 is easy to plug in. Plug in 0, you get 0, 0, 12. 0 and -16. So 12 divided by -16. Give me a decimal if you wouldn't mind, someone. 2.4? Okay. So 0, 2.4.
Oh, wait, and I'm sorry.
Yeah, 12 divided by 16. Okay, yeah, that didn't make sense. I should have thought about that before I wrote that down. Yes, -0.75. Yeah, I should have gone with that. I wasn't thinking. Okay. So look, 0 and it's down, isn't it? So can we cross the x-axis? So we must be like down here, right? Okay, good. And then I'm going to go ahead and plug in like -3. If I plug in -3, I get out, I don't know. Our x-intercepts are these and only these, right? They come from the numerator. So if plug in -3, you're going to see how to fix this weirdness we have going on over here. Because that is weird. Like, for example, is it coming up and then hugging? Is it coming down then hugging? What'd you get? Okay, -3 up to, okay, so we know we're in this section. Okay, so now look how this is weird. So I was like trying to figure out, do we come down and then cross and then hug? Or do we come up and then hug? Does that make sense? Now don't be weirded out that from here to here it's 0, right? I can stay on the 0 like that. So the question is, I need to figure out, yes, 2.5, you're so smart. Yes, we need to figure out if this is up or down, because we're not supposed to say students are smart. 2.5, plug in 2.5, plug in 2.5, go, go. Okay. 0.75, everyone. So that means actually I'm going over to 2.5 up here, aren't I? Because this was 0.25, so it's above. So then what's happening? What's happening is it's coming down off of this asymptote, it's crossing, hugging, and then shouldn't it come up by this asymptote? That's a good one. Because I didn't know for sure if this was coming up like this and then hugging, or coming down. Which luckily is still above 0.25, right? So we're on the right track. 0.8 is just a little higher, right? Same idea. It's 0.08? Okay, but still heading in the upward direction. True? Yeah, below, but isn't it still up though? Heading upward? You didn't say negative. Does that make sense? Oh yeah, okay. All right. I think we're probably good without this example. Okay. Okay, finish the worksheet.